Have you ever pondered over the possibility of multiple universes, each with its own set of rules and realities? This is the multiverse conundrum, a concept that might seem like the stuff of science fiction, but is actually a topic of serious debate among physicists and cosmologists. It's a captivating idea that challenges our understanding of reality and existence. Imagine, if you will, our universe as a single bubble. It's vast, infinite, and filled with galaxies, stars, and planets. But what if this bubble is just one among an infinite number of other bubbles, each one a universe in its own right? This is the essence of the multiverse theory, a concept that suggests there could be countless other universes, each potentially governed by a unique set of physical laws. There are various types of multiverses that scientists speculate about. Parallel universes, for instance, are believed to exist side by side with our own, each one a mirror image or an alternative version of reality. Imagine another universe where dinosaurs never went extinct, or where the laws of physics are so different that time flows backward. Then we have the concept of daughter universes, which are thought to be born from black holes. These universes are theorized to exist in a separate space-time, creating an entirely new set of realities and possibilities. Finally, we come to mathematical universes. These are not physical realities, but abstract constructs that exist purely in the realm of mathematics. They are based on the idea that any structure that exists mathematically also exists physically in its own universe. The multiverse hypothesis is a thrilling and mind-bending concept. It forces us to stretch our imaginations and question our understanding of reality. It's like peering into a cosmic kaleidoscope, where each turn reveals a new pattern, a new universe, a new reality. As we dive deeper into this fascinating concept, prepare to question everything you know about reality. The origins of the multiverse theory can be traced back to quantum mechanics and the intriguing double-slit experiment. The double-slit experiment, for those unfamiliar, is a demonstration that light and other forms of quantum matter can display characteristics of both particles and waves. When we fire particles at a panel with two slits, we might expect them to act like tiny bullets going through one slit or the other. But what we observe instead is an interference pattern, as though the particles are acting like waves. This experiment posed a fundamental question: how can a single particle go through both slits at the same time? The answer lies in the mind-bending concept of quantum superposition. Quantum superposition is the principle that any two or more quantum states can be added together or superposed, and the result will be another valid quantum state. In the context of the double-slit experiment, a particle exists in a superposition of states, going through both slits simultaneously until it is observed or measured. This led to a radical shift in our understanding of reality. If a particle can be in two places at once, could the same be true for larger systems or even for the universe itself? This is where the idea of the multiverse was born. The multiverse theory suggests that our universe is not the only one, but exists in a state of superposition with an infinite number of other universes. Each of these universes represents a different possibility, a different reality. Every time an event occurs, from the motion of a particle to the actions of a person, the universe splits into multiple versions, each one representing a different outcome of that event. In essence, with every decision, every action, we might be creating an infinite number of parallel universes. Scene script. Imagine a universe where you are an astronaut, exploring the far reaches of space. This is what the many worlds interpretation, a theory in quantum mechanics, allows us to do. In essence, it suggests that there isn't just one universe, but rather an infinite number of universes, each corresponding to a different outcome of every decision or event that ever occurred. Quite the mind-bender, isn't it? So, how does this work? Picture it like this. Each time a decision is made or an event happens, the universe splits. In one universe, one outcome happens, but in another universe, a different outcome occurs. This creates an almost unfathomable number of parallel universes, each distinct yet subtly linked. For instance, in this universe, you're listening to a voiceover about the many worlds interpretation, but in another, you might be the one teaching it. In yet another, you might not have even discovered this video. It's like a cosmic game of what if played out across an infinite cosmic stage. This interpretation, as groundbreaking as it is, challenges our very understanding of reality. It implies that every possibility that could ever exist does exist somewhere in the multiverse. It's a concept that can make us feel incredibly small, yet infinitely significant at the same time. After all, in some universe out there, you're the one defining the laws of physics. But it also brings a sense of unity. Even though we may feel isolated in our own universe, we're part of a much larger, infinitely varied multiverse. Every decision we make, every event we experience, contributes to the rich tapestry that is the multiverse. The many worlds interpretation opens up a world, or rather an infinity of worlds, of possibilities. It reminds us that our universe is just one of an infinite number, each with its own unique story to tell. In another universe, you might already know all about the multiverse. But how can we prove the existence of the multiverse? Well, that's the million-dollar question, isn't it? Let's take a look at the current scientific evidence that supports the multiverse theory. First up, we have cosmic inflation. This theory proposes that shortly after the Big Bang, the universe expanded exponentially before slowing down to a more leisurely pace. Now, if this inflation were to occur in multiple different areas, it could create a multitude of universes, each with their own unique properties. Interesting, right? But it's not just cosmic inflation that points towards the existence of a multiverse. Quantum mechanics also offers a compelling argument, specifically through the phenomenon of quantum entanglement. This is when two particles become linked, and the state of one particle instantaneously affects the state of the other, no matter how far apart they are. Some scientists argue that this could be evidence of multiple universes where all possibilities are played out. However, it's not all smooth sailing for the multiverse theory. There are, of course, controversies and criticisms. One of the main criticisms is that the multiverse theory is untestable. While cosmic inflation and quantum entanglement are compelling, they don't provide concrete proof of a multiverse. They're merely suggestive of its existence. Another point of contention is the issue of Occam's razor, the philosophical principle that the simplest explanation is usually the correct one. Critics argue that the multiverse theory, with its infinite universes, is far from simple and therefore less likely to be true. Then there's the issue of the anthropic principle, which suggests that the universe is fine-tuned for human life. Some critics argue that the multiverse theory is just an attempt to explain away this fine-tuning rather than providing a satisfactory explanation for it. So, while the multiverse theory is undoubtedly fascinating, it's also a hotbed of controversy. It's a theory that challenges our understanding of the universe and our place within it. And while it has its fair share of critics, it also has a wealth of potential, opening up new avenues of exploration and understanding. The multiverse theory, while fascinating, still has a long way to go before it can be universally accepted. So what does the existence of a multiverse mean for us? That's a question that's been keeping philosophers and scientists up at night. The implications of the multiverse theory are vast and varied, challenging our understanding of reality and our place in the cosmos. When we think about the multiverse, it's easy to feel small. After all, if there are an infinite number of universes, each with its own set of physical laws and constants, where does that leave us? It's a humbling thought. It forces us to reevaluate our place in the grand scheme of things. No longer are we the center of the universe, but rather, we are a small part of an unimaginably vast cosmos. Yet this doesn't diminish our significance. Rather, it amplifies it. Each decision we make, each action we take could potentially create a new branch in the multiverse. Our lives, our choices matter on a cosmic scale. The multiverse theory also has profound implications for the nature of reality itself. If the multiverse exists, then reality is no longer a single, unified entity, but a collection of distinct universes, each with its own unique properties. This challenges our conventional understanding of reality as a singular objective truth. Instead, reality becomes subjective, dependent on which universe you find yourself in. In the realm of science, the multiverse theory forces us to rethink our theories and models. We may have to incorporate the multiverse into our understanding of physics and cosmology, opening up new avenues of research and exploration. The multiverse could be the key to unlocking the mysteries of the cosmos, from the nature of dark matter and dark energy to the origins of the universe itself. So while the existence of a multiverse may seem daunting, it's also incredibly exciting. It presents us with new challenges, new questions, and new possibilities. It pushes us to rethink, to question, to explore. In the grand scheme of the multiverse, we are but a small part of an unimaginably vast cosmos. But within that cosmos, we have the potential to make a world of difference.